This is the EdExcel A-Level Maths Paper 3 from the 2023 series, and in this paper we will be taking a look at the mechanics section. Question number 1. A car is initially at rest on a straight horizontal road. The car then accelerates along the road with constant acceleration of 3.2 meters per second squared. Find for part A the speed of the car after 5 seconds. In this question we are dealing with constant acceleration, and therefore we have to use the Suva equations shown here. We are told the car is initially at rest. It has constant acceleration of 3.2 meters per second squared. We are finding the speed of the car after 5 seconds, which means then we have to use the formula P equals U plus AT. So, for part A, using V equals U plus AT, V is what we are finding, and this is equal to U, which is 0, plus A, which is 3.2, multiplied by T, which is 5, and therefore you will find V to equal 16 meters per second. Part B, we have to find the distance travelled by the car in the first 5 seconds. We are finding the distance travelled by the car in the first 5 seconds. So, the Suva we are required to use is S equals UT plus a half AT squared. Therefore, using S equals UT plus a half AT squared, we have S, which is what we are finding, equaling U, which is 0, multiplied by T, which is 5, plus a half, multiplied by A, which is 3.2, multiplied by T, which is 5, and then squared. So working this out, you will find S to equal 40 meters. Question number 2. A particle P has mass 5 kilograms. Particle is pulled along a rough horizontal plane by a horizontal force of magnitude 28 newtons. The only resistance to motion is a frictional force of magnitude F newtons, as shown in figure 1. For part A, we have to find the magnitude of the normal reaction of the plane on P. To begin with, what we know is the particle P has a mass of 5 kilograms, as shown here. We've got this horizontal force of magnitude 28 newtons, shown here. We've got this resistance to motion, F newtons. We are finding the normal reaction. The normal reaction R is shown here. And what we have is an equal and opposite force to this, mg. M is 5. We multiply that by gravity. So we have 5g, as shown in the diagram. For part A then, R is equal to 5g, and therefore we find R to equal 49 newtons. The particle is accelerating along the plane at 1.4 meters per second squared. For part B, we have to find the value of F. What we know so far is the particle is accelerating along the plane at 1.4 meters per second squared. Now, what we can do in this question is find out what F is using the sum of the forces equals the mass multiplied by the acceleration. We've got this forward force of 28 newtons, and we've got this frictional force opposing it. We know what the mass is, and we are told what the acceleration is. Therefore, for part B, using the sum of the forces equals mass times acceleration, we have 28, the forward force, subtract the resistive force F. This is equal to the mass 5 multiplied by the acceleration 1.4, and what we are required to do is find out what F is. To find out what F is, that's equal to 28 subtract 5 multiplied by 1.4, which is 21. So F is 21 newtons. The coefficient of friction between P and the plane is mu. For part C, we have to find the value of mu, giving an answer to two significant figures. So we know we have our coefficient of friction between P and the plane being mu, and therefore to find mu, we have to use F equals mu r. So we have 21, that's what F is, equaling mu, which is what we are finding, multiplied by r, which is 49. So therefore, to find out what mu is, we would have to do 21 divided by 49, which to two significant figures is 0.43. Question number 3. At time t seconds, where t is greater than or equal to 0, a particle p has velocity v meters per second, where v equals t squared subtract 3t plus 7 in the I direction and 2t squared subtract 3 in the j direction. We have to find for part A the speed of p at time t equals 0. For part A, when t equals 0, we can find out what v is. V will equal 7i subtract 3j. And what we are required to do is find the speed of p when t equals 0. So therefore, the speed is equal to the square root of 7 squared plus negative 3 squared, and if we work out what this is equal to, we have the square root of 7 squared plus 3 squared, which is root 58. As a decimal, we have 7.62 meters per second to three significant figures. For part B, we have to find the value of t when p is moving parallel to I plus j. Well, if it's moving parallel to I plus j, we can therefore say the I component is equal to the j component. So if the I component is equal to the j component, we have the I component, t squared subtract 3t plus 7. This is equal to the j component, 2t squared subtract 3. If we rearrange this, you will find t squared plus 3t subtract 10 to equal 0. We can factorize this as t plus 5 multiplied by t subtract 2 equals 0, and therefore t is equal to negative 5, or t is equal to 2. Which means then, t is equal to 2 seconds, and that's because t is greater than or equal to 0. For part C, we have to find the acceleration of p at time t seconds. Part C, we know what v is, that's given by t squared subtract 3t plus 7 in the I direction, plus 2t squared subtract 3 in the j direction. We are required to find the acceleration, and the acceleration is equal to the derivative of the velocity with respect to time. So if I differentiate in the I direction, we end up with 2t subtract 3. And if I differentiate in the j direction, we end up with 4t. So the acceleration is given by 2t subtract 3 in the I direction plus 4t in the j direction. Part D, we have to find the value of t when the direction of the acceleration of p is perpendicular to I. Well, it's perpendicular to I when the I component is equal to 0. So, when the I component is equal to 0, we have 2t subtract 3 equaling 0, which means then if I solve for t is equal to 1.5 seconds. Question 4. In this question, I and j are horizontal unit vectors, and position vectors are given relative to a fixed origin O. A particle P is moving on a smooth horizontal plane. The particle has constant acceleration 2.4i plus j meters per second squared. At time t equals 0, p passes through the point A. At time t equals 5 seconds, p passes through the point B. The velocity of p as it passes through A is negative 16i subtract 3j meters per second. We have to find for part A the speed of p as it passes through B. What we know is we have constant acceleration 2.4i plus j meters per second squared. We know at time t equals 5 seconds, it passes through the point B, and at time equals 0, it passes through the point A, and the velocity when it passes through the point A is negative 16i subtract 3j, which means our initial velocity is negative 16i subtract 3j. As we have constant acceleration, we are required to use the Suva equations. We will be using v equals u plus at. Therefore, using v equals u plus at, we are finding out what v is. This is equal to u, which is negative 16, negative 3, plus a, which is 2.41, multiplied by t, which is 5. And if we work this out, we end up with negative 4, 2. Which means the speed is equal to the square root of negative 4 squared plus 2 squared. And if we work out what this is equal to, 4 squared plus 2 squared is 4.47 meters per second to 3 significant figures. The position vector of A is 44i subtract 10j meters. At time t equals t seconds, where t is greater than 5, p passes through the point C. The position vector of C is 4i plus cj meters. We have to find the value of t. So what do we know so far? Well, we know that the position vector of A is 44i subtract 10j meters. At time t equals t seconds, p passes through the point C, and the position vector of C is 4i plus cj. What we can do to begin with is find out the vector AC. The vector AC is equal to the vector OC subtract the vector OA. So we have the vector OC, which is 4c, subtract the vector OA, which is 44, negative 10. And if we work out what this is equal to, you will find the vector AC to equal negative 40, 10 plus c. As this is our position vector, what we are required to do in this question, again, because we have constant acceleration, is use the Suva equations. We will be using s equals ut plus a half at squared. So, using s equals ut plus a half at squared, we have s, which is negative 40, 10 plus c, equaling u, which is negative 16, negative 3, multiplied by t, plus a half multiplied by a, which is 2.41, multiplied by t squared. Now what we are required to do in this question is find out what t is. And to find out what t is, what we can do is consider the I component. The reason for that, if I consider the j component, I would have this unknown value of c, which will not help me find the value of t, which is why we consider the I component. So in the I component, we have negative 40 equaling negative 16t plus a half times 2.4 times t squared. So we have negative 40 equals 16t plus 1.2 t squared, meaning we have 1.2 t squared subtract 16t plus 40 equals 0. And if I multiply through by 5, we have 3t squared subtract 40t plus 100 equals 0. And if I factorize, I have 3t subtract 10 multiplied by t subtract 10 equals 0, meaning t is equal to 10 over 3, or t is equal to 10. Therefore, t is equal to 10 only, and that's because t is greater than 5. We now have to find the value of c. For us to find the value of c, we need to consider the j component. The reason for that, the j component contains the c, which is what we are finding. So considering the j component, we have 10 plus c equaling negative 3t plus 0.5 times t squared. And if I substitute in the t equals 10, we have 10 plus c equals negative 3 times 10 plus 0.5 times 10 squared. So if I work out what this is equal to, well, I have negative 30 plus 50, and then if I subtract the 10, you will find c to equal 10. Question number 5. A small ball is projected with speed 28 meters per second from a point O on horizontal ground. After moving for t seconds, the ball passes through the point A. The point A is 40 meters horizontally and 20 meters vertically from the point O, as shown in figure 2. The motion of the ball from O to A is modelled as that of a particle moving freely under gravity. Given that the ball is projected at an angle alpha to the ground, we have to use the model to show for part A that t equals 10 over 7 cos alpha. We've got our initial speed, 28 meters per second. It takes t seconds to go from O to A. The point A is 40 meters horizontally and 20 meters vertically from the point O. And we model the ball and its motion as a particle moving freely under gravity. What we can do is consider the horizontal motion, and for this we will use the suva s equals ut plus a half at squared. So for part A, sx is equal to ut plus a half at squared. Sx is 40. This is equal to the horizontal component of the velocity 28 cos alpha. We multiply this by t. We add on to this a half multiplied by the horizontal acceleration, which is 0, multiplied by t squared. And if I divide through by 28 cos alpha, you will find t to equal 10 over 7 cos alpha. Part B, show that tan squared alpha subtract 4 tan alpha plus 3 equals 0. This time we will consider the vertical motion. Using s equals ut plus a half at squared vertically, we have sy equals ut plus a half at squared. So sy is 20. This is equal to the vertical component of the velocity 28 sine alpha multiplied by t. And then we subtract, because we assume gravity to be acting downwards and we're taking upwards to be positive, 0.5 multiplied by 9.8 multiplied by t squared. And I already know what t is, that's 10 over 7 cos alpha. So we have 20 equals 28 sine alpha multiplied by 10 over 7 cos alpha, subtract 4.9 multiplied by 10 over 7 cos alpha squared. So we have 20 equals, now here we have 28 multiplied by 10 divided by 7 multiplied by sine alpha over cos alpha, so that's the same as 40 tan alpha, and then we subtract 4.9 times 10 over 7 cos alpha squared, which is negative 10 sec squared alpha, because 1 over cos alpha squared is the same as sec squared. So I've got 20 equals 40 tan alpha, subtract 10 multiplied by sec squared, and sec squared is the same as 1 plus tan squared alpha. So I've got 20 equals 40 tan alpha, subtract 10 tan squared alpha. Which means if I simplify this, we end up with tan squared alpha subtract 4 tan alpha plus 3 equals 0. For part C, we have to find the greatest possible height in meters of the ball above the ground as the ball moves from O to A. Well, we are finding the greatest possible height. And if we consider the vertical motion, we will be using the suva v squared equals u squared plus 2as. Now, let's first of all think about this tan squared alpha subtract 4 tan alpha plus 3 equals 0. We can factorize this as tan alpha subtract 3 multiplied by tan alpha subtract 1, and this is equal to 0, which means then tan alpha is equal to 3, or tan alpha is equal to 1. And the greatest height occurs when tan alpha is equal to 3. So we have vy squared equals u squared plus 2as. So we have 28 sine alpha squared equals u squared, so that's 0 squared, plus 2 multiplied by 9.8 times by s. Now we know that tan alpha is equal to 3. And if I draw a right-angled triangle, such as the one we see here, tan is equal to the opposite over the adjacent. So we've got the 3 being the same as 3 over 1. So the opposite is 3, the adjacent is 1. And using Pythagoras, we can find the hypotenuse. The hypotenuse then is root 10. And we can use this to help us find out what sine alpha is. So therefore, sine alpha is equal to 3 over the square root of 10. Meaning, we have 28 multiplied by sine alpha, so that's 3 over root 10 squared, and this is equal to 19.6, which is the same as 2 times 9.8, multiplied by s. And what we are required to do is find out what s is, and we can do that using our calculator. We have 28 multiplied by 3 over the square root of 10. Then we square this and divide by 19.6, and it turns out then s is equal to 36 meters, which is the greatest height. The model does not include air resistance. For part D, we have to state one other limitation of the model. Well, the ball is being modelled as a particle, so its size is not being taken into account, which is a limitation. Question number 6. A rod AB has mass m and length 2a. The rod has its end A on a rough horizontal ground and its end B against a smooth vertical wall. The rod makes an angle theta with the ground, as shown in figure 3. The rod is at rest in limiting equilibrium. For part A, we have to state the direction, left or right, on figure 3 above, of the frictional force acting on the rod at A. Give a reason for your answer. The way to think about this, we've got the position of the rod as shown here. if the rod starts to move, what will end up happening is something like this, whereby the rod moves like this, whereby B moves down a little and A moves a little to the left. And so what we're saying is the rod is moving towards the left. What will oppose the driving force, if you will, is a frictional force. And this frictional force, F, will act in the opposite direction towards the right. So friction is to the right. The only horizontal forces are friction and the normal reaction force at B, which must be in opposite directions for equilibrium. The magnitude of the normal reaction of the wall on the rod at B is S. In an initial model, the rod is modelled as being uniform. Use this initial model to answer parts B, C and D. For part B, by taking moments about A, we have to show that S is equal to 1/2 mg cot theta. Let's show all the relevant forces on our diagram. We've got the weight of the rod, which acts along its centre. That's given by mg, which means from A to this point here is A, and from this point to B, that length is also A. We've got the frictional force F. We've got the reaction at the point A. We know the magnitude of the normal reaction of the wall on the rod at B is S, and that's shown here. And what we have to do is take moments about A. So, for part B, if we take moments about A, well, we have clockwise equaling anti-clockwise. The mg is acting clockwise and the S is acting anti-clockwise. So if I think about what's going clockwise, we have the length A, and we multiply that by the perpendicular force, which is given by mg cos theta. So this is clockwise. And anti-clockwise, well, we've got this length 2A, and we multiply this by the force of S sine theta. And noticing that the A's cancel on both sides, we can therefore say that S is equal to mg cos theta over 2 sine theta. So therefore S is equal to 1/2 mg cot theta. Cos theta over sine theta is cot theta. The coefficient of friction between the rod and the ground is mu. Given that tan theta is 3/4, we have to find the value of mu. So we've got this coefficient of friction being mu. Now, for us to determine what F is, we need to first of all consider the vertical forces. So what's acting vertically here? Well, I've got this R and this mg acting vertically, which means then I've got R, which is equal to mg. So if I use F equals mu R, I've got F equals mu multiplied by R, which I know is mg, so F is equal to mu times mg. Let's now consider what's acting horizontally. Well, I've got this F and this S acting horizontally. So I've got F equals S. Now I know what F is, that's mu times mg, and this is equal to S, which is a half mg cot theta. So the mg's cancel on both sides, so I've got mu equals a half times cot theta, and cot is the same as 1 over tan, and I know what tan is, that's 3/4. So mu is equal to this 1/2 times by cot theta, which is 4 over 3, because tan theta is 3/4. And therefore, if I solve for mu, we'll find mu to equal 2/3. Part D, we have to find in terms of m and g the magnitude of the resultant force acting on the rod RA. Before we do anything else, let's find out what F is. For part D, F is equal to mu, which is 2/3 multiplied by mg. So F is equal to 2/3 mg. For us to find out what the resultant force is at A, we would have to use Pythagoras. So the resultant force, that's equal to the square root of r squared plus f squared. I know what r is, I know what f is. So I've got the square root of mg squared plus 2/3 mg squared. And if I factorise out an mg, I've got mg multiplied by the square root of 1 plus 2/3 squared. So if I work out what the square root of 1 plus 4 over 9 is, I get root 13 over 3, which means the resultant force is given by mg times root 13 over 3 newtons. In a new model, the rod is modelled as being non-uniform, with its centre of mass closer to B than it is to A. A new value for S is calculated using this new model with tan theta equaling 3/4. We have to state whether this new value for S is larger, smaller, or equal to the value of S would take using the initial model. Give a reason for your answer. Well, for part E, the new value would be bigger. Let's think about why that's the case. When taking moments to calculate S, in the formula S equals half mg cot theta, this 1/2 is the ratio of the two distances. So we would have A to 2A. So that means then A has been replaced by a larger value because its centre of mass is closer to B than it is to A this time, which is why the new value would be bigger.